3, applications of reference angles and the cast rule. So we're taking what we know with reference angles and cast rule and applying them. Again, just quick review. Reference angle is the angle or position back to the x-axis. Cast rule tells you what's positive or negative and where. Okay. So in this lesson, we're going to determine the exact trig ratios for rotation angles 0 to 360, given a point on the terminal arm. We're going to determine trig ratios for rotation angles 0 to 360 from a different trig ratio for the angle, and then we're going to solve equations in the form of sine theta equals something, cos theta equals something, and tan theta equals something. So it's going to be the inverse stuff. We did talk about that a little bit already. So the reference angle for any rotation angle is the angle between the terminal arm and the x-axis. So I've already said this. Okay, for those guys who are gone. So if you have this angle here, this is the angle that it makes, but the reference angle comes from the distance back to 180. So that's why it's 180 minus the reference angle equals the rotation. So if our reference angle is 30, 180 minus 30 would be 150. That means that this is 150, just for context. Quadrant 1, it's easy. Your reference angle equals your rotation angle. Quadrant 3, you add the reference angle to 180 to get your rotation angle. And in quadrant 4, it's 360 minus the reference angle to get the rotation. Okay, we've already talked about this in previous notes, so we don't have to go over it any further. Here's a review of cast rule. So cast rule tells you it starts at the bottom right corner, so it actually starts in the 4th quadrant for the abbreviation, which can be a little confusing. But starts in the bottom right, that means cosine's positive, that's all. It means sine's negative and tangent's negative. Everything's positive in quadrant 1, sine's positive in the top left, and tangent's positive in the bottom left. And so if that's positive there, the other stuff is negative. And then just from the warm-up here, here's a review of all the ratios, which we just wrote those down. So we don't need to go over those again. All right. So exact values. Biggest thing we have problems with when it comes to these is people keep wanting to write things with decimals. Remember, exact is you have to be able to simplify the fraction or simplify the radical appropriately. So when it says it wants something exact, if you just plug in your calculator and put 2.68, it's not correct. Okay? You have to be able to write these in the ratio. So the point negative 3,2 lies in the terminal arm for angle theta in standard position. Complete the following procedure to determine the values of the primary trig ratios. So we're going to sketch the rotation angle on the grid and mark the point negative 3,2. Okay, so negative 3, 2. So this is where it's at. So we're going to draw the arm down to the center. Okay, and so what we're looking at is we are looking at this rotation angle. Okay, down to there. So what we need to do now is we need to go ahead and complete this. So we do our ratios. We know what x and y is right now. We know that my x is negative 3, my y is 2. I need to figure out what r is, which r is OP, right? Whenever it says O, that means origin. So here's O, this is P, so they want us to find the OP, which is R. So that's going to be, you can leave the negative in there because you're squaring it, so it's not really going to affect your answer if you do it negative or positive, because it's going to be positive either way when you square. So it's going to be 9 plus 4, so you're going to get 13. So then R is root 13. In this case, that's OP. Okay. Questions on that? Okay, so when you look at that now, it says x is negative 3, y is 2, and r from above, write the 3 trig ratios. Okay, so Jared, what is sine? Sine theta. Good. 2 over root 13, so y over r. Rationalize just for practice. It's going to be 2 root 13 over 13. Okay. Abby, what's cosine theta? Yeah, backwards. Negative 3 on top. It's x over r. So it'd be negative 3 over root 13. You get the right numbers. Okay. So x on top, root 13. So if we rationalize, maybe that's what you were doing. If you rationalize, it's negative 3 root 13 over 13, like that. Okay, and Riley, you want to take a shot at tan theta? Good. 2 over negative 3. Yes. Yep. Now I want to show you guys something, that this is not a coincidence. Okay, I wrote negative 2/3. I know the 3 is negative, but the whole thing's negative, right? So it doesn't really matter where the negative's at. But I want to show you something. Which quadrant are we in? 2. And sine, cosine, or tangent, which one was positive? Sine. This was positive. These two are negative by the cast rule. So it all falls in line. Kind of comes full circle. Okay? Good, because we can't have a negative length for r. Okay? We can't have a negative length for r. Yeah. All right, so anyway, we got that. Let's try another one. Point -4, -2 lies on the terminal arm for angle theta and standard position. Determine the exact value for sine theta. We're just doing one. We are going to need to find r, however, right? Because sine theta, we need r. We know we're in the third quadrant. Is sine positive or negative in the third quadrant? Negative. So I know my answer for sine theta. We can just go ahead and just get this started. My theta's been awful today. It's going to be negative something, if you want. What's that? It looks like a pi. All right, let's try this again.
I said it looks like I.
Oh, an I. Okay, sorry. You can put x, is fine. Theta is just a variable for, but if you just have sine with nothing, we need to have something there. Yeah. But you can use x, is fine if you don't like it. 1, 2, 3, 4, 1, 2. There's my terminal arm. So I need to figure out what my r is, so I have y and r. Okay, so we are going to go -4 squared plus -2 squared equals r squared. 16 plus 4, we get 20. Since we already did the radical section in this class, I know it was a long time ago, Unit 1, we are going to break down the 20. 2√5 is what r is. So the reason we do that is because it's going to help your simplifying. So y is -2 over 2√5. And you can see the 2's cancel. So this answer is -1 over √5. And what can I do to that? Right, we'll go like this, we'll rationalize. So -1 radical 5, like you said, over 5 is the actual exact value, fully simplified. They never will, like for your tests or anything like that, the answers that are given to you will always have the radical on top. Yep. Well, all this is a trig ratios question. To do sine, we need y over r. So r is a hypotenuse. What's that? We'd have to have at least have 2 out of the 3 somehow. But then if we have r, then we'd have to know it's either a 45 degree or we'd have to know one of these. We can't find 2 missing lengths from one radius, is what I'm saying. Because there's a lot of options that that's true. So you have to get 2 out of 3 is what I'm saying. Right. Is that what, say? Okay, so value of trig ratio given a different trig ratio. So now we're given sine, and we want to find cosine and tangent. So when you get these, you're going to realize that you're given sine, you're given 2 values, right? You know y and r are 5. Now, do you know which one's negative? No, except for it tells you the third quadrant. So third quadrant is sine negative there? Yes. So you know it's a -4 and 5. R is always going to be positive, so don't worry about r being negative anyways. But you have to look at all the information they give you, and it tells you what's positive or negative where. Okay, so it's telling you, since sine of A is -4 or 5, you know -4 or 5 is y over r. So we know the point is x -4. We know -4 because it's in the third quadrant. We're down here. So down here, sine is negative. Okay, and so then along with this kind of, I guess, Brett, this is actually what you're kind of asking. So we know y and r, so we have to figure out what x is now. So we're going to go x squared plus -4 squared equals 5 squared. We know the 4, 5 pattern, right? What's x going to be? 3, right? It's always that common one. Okay, if you want to do the work, it's going to be 16, subtract the 25 from 16. So, subtract 16 from 25. So you're going to get x squared is 9, and then you square root. You get 3, and then we know that it's going to be what type of 3? No, it's negative because we're this way. It's left. Okay, so we determined the value of x. We just did this, so it's going to be x equals negative 3. So let's determine the quadrant. Sketch the diagram. So the diagram is it's going to be, we know it's going to be 5, and we know that y is 4. We're not sure what this was. That's what they want us to sketch there. Okay. And we'll go down there to the next part. It says use the values of x, y, and r to determine the exact values of cos A and tan A now. So we know x is negative 3. We're just going to write the value of cos A and tan A. Which one of those are going to be positive? Tan. Tan A should be positive. So cos A will be negative 3 over 5. Tan A will be 3 over 4. Nope, 4 over 3. Positive. Because it's negative over negative. You can put that if you want and then show it's positive, but that's where we're going.
How do you know that y is negative?
Because it says we're in the third quadrant in the very beginning. So since we're in this quadrant, negative x, negative y down here, right? R is always positive, essentially, for these problems. Because R is defined as a distance out from the origin, so it's a distance. And so the x and the y's gives you combinations of that. And so we just keep that positive all the time. Okay, any other questions?
So when you put the calculators,
Yes. So cos, but like it'd be cos inverse of 4/3 and cos inverse of negative 3/5. If you were solving for A, they should have the same A. Yeah, and we're going to talk about that in a little bit. Okay, all right, so tan theta is negative 2/3. Cosine theta is positive. Find the exact value of sine. So this is what they're telling you. Tangent's negative. So right away, guys, this is what your thought process should be with CAS rule. If tan is negative, you are in here or in here, right? Then it tells you cosine's positive. So where am I, 2 or 4? 4. I'm in this section. Does anybody have any questions about that? Tangent is negative, so that means we're in 2 or 4. Cosine is positive. Positive x is to the right. So it puts us in quadrant 4. Okay. Find the exact value of sine theta. So again, we do have, this means that the 2 here is the negative. That's your y. And that your, excuse me, 3 is positive. That's your x. Y over x, right? Tangent's y over x. So that means we have a negative 2 and a positive 3. So we're going to find r. Because we need sine theta, we're looking for y over r. So right now our answer, we already know half of it. Our answer is negative 2 over something. We got to find the something. 4 plus 9, we got that 13. And that's r squared there, sorry. 13 is r squared. So r is root 13. So we got root 13 here. Go ahead and practice our rationalizing one more time. That's your value of sine theta rationalized. Okay. Okay, so now we're going to talk about finding positions. Okay, so what we are finding is finding the ratios. Okay, so the cool thing about trigonometry is every sine or cosine, depending on the r, has the same ratios. Or consistent ratios, not same, I guess you could say. All right, so now solving equations involving sine, cosine, and tangent, we're going to talk about how to find the a. For example, sine theta is 0.5. Well, where is sine theta 0.5? Where is that true? Okay, a couple things you got to consider. It says where is sine A 0.5? Is 0.5 positive or negative? How many spots is that possible? There's 2 places that sine's positive, right? So we need to think about these in pairs. Okay? So sine is 0.5 in 2 locations. All right, and we're going to show you how to get the second location with your calculator. Okay, so here's what we're going to do. This is a follow procedure for solving a sine theta equals 0.5. Determine the quadrants the angles will be in. So that's what I just asked you. So sine is positive in 1 and 2. So my answer is going to be on the top, right, because sine's positive. Then it says determine the reference angle. The work you do on your calculator kicks out your reference angle. So we're going to do that. What it does is it tells you the reference angle. You use that reference angle to find the quadrant value. Okay, I'll tell you what that means in a second. Okay, when you do sine inverse or whatever this is, we're always going to do the absolute value because we want to just stay in, like, we're going to pretend everything's in quadrant 1, whether it's not, doesn't matter, because it's going to give us the reference angle we can use in any quadrant. Let me say that again. We're going to do always sine inverse, cosine inverse of whatever this number is, but positive, so that we can kind of stay in positive land and we'll adjust as we figure out where we're trying to go. Okay, so I'll explain what that means too. Okay, and we determine the reference angle from the rotation. So let me show you. Sine theta 0.5. So that's what you're going to do. You're going to go sine theta 0.5. This is the part of algebra I want you to think about. We're solving for theta. Theta stands for position. We're staying in degree land. So I know our unit circle project, we were talking about radians. We're staying with unit, degrees. So make sure your calculator's in degree. If not, you'll get it wrong. Okay? So just like anything, we undo stuff, right, in algebra? So to undo a sine is a sine inverse. And so we sine inverse 0.5 in our calculator, and it'll kick out the degree of that. Okay? Let me go ahead and pull up my calculator here. So you can see, so we're going to go second sine 0.5. I don't think I'm in radians. Hold on. Let me switch to see I'm in radians. That's wrong. I need to be in degree mode. Okay, there goes second quit. And now I'll hit enter. 30. So 30 degrees is where sine is 0.5. 30 degrees where the reference angle. So you ask yourself now, this is what we have to do. So we say, okay, so we did this work. Sine inverse of 0.5 is 30. Where is sine positive? Sine is positive here and here. Oh, so 30 is an answer. My other answer is going to be here, 30, which is, how do I find this? Right, 180 minus 30, so 150. Those are your two answers. So, figure out which quadrants you're in, find the reference angle, do the work to figure out what the value is with that reference angle in that quadrant. Okay? Okay, any questions? So, this is what I'm going to kind of explain these ones. So like right now, let's just go through and figure out where we're expecting these answers to be. We'll do that first, and then we'll do the calculating second. Okay? Sine is negative. So where's this one at? 3 and 4. Cosine's negative. Where are we at? Tan's negative. Right? So that's where we're at. Now, do sine inverse, and remember it's an absolute value. So we're just going to put 0.8090 into our calculator. And we're going to do that for all three of them. Cos inverse 8090. I would just put them in positive, absolute value of them, because it's going to tell you the positive reference angle. Okay, so that's what we're putting in. What did you get for the first one? Right, it says round the nearest degree, so it should be 54. Okay, it says round the nearest whole degree. Let's do all the find them, and we'll do the second. We'll do them in sections here. So what's the degree of the cosine one? 36. We're going to do that last. We're just finding the reference angles of all three, and then we'll do the work to finish for all three. Okay, what about tangent? 68. Okay. All right, so that's my reference angle line. So we found the reference angle for all of them. Okay, and now we're going to find the answers. So if reference angle is 54, I'm in 3 and 4. So I'm going to do 180 plus 54 for that one. So that's going to be 234 is an answer. And I'm going to do 360 minus 54, 306 degrees is an answer. Okay, because essentially I'm right here, right? I'm right there, and I'm right there. 360 minus 54. Yep, to get these I did, so this one was 180 plus 54. This one was 360 minus 54. That's how I got those two answers there. Okay, cosine of 36. I'm going to find the one before 180, the one after 180. So I'm going to go 180 minus 36, 180 plus 36. So 180 minus 36 is 144. 180 plus 36 is 216.
Christian, more to the office, please.
So basically the angles you get from the inverse function.
That's the reference angle to get, yeah. You got the reference angle first, and then what quadrant are you in second?
So if you got a negative answer, would you just
Yeah, you got a negative answer because you put a negative value in. We want to put positive values in, that won't happen. But if you do, that's still a reference angle. Okay, and then tan 68, so we know we're in 2 and 4, so that's 180 minus 68, so that's 112. And then it's 360 minus 68, so that's 292. Oh, yeah, 292. Misprint on this one. Okay. Questions? So you can see, guys, we're doing all these things full circle, okay? Is like really makes a sense of like your degrees, your measurements, and all that stuff. Okay. Onward. Okay, last couple. Solve the following. 0, 360. So sine theta is 1. Now, my unit circle people that were here for the stuff on that, where is sine 1? Okay, just 90, right? 270 is negative 1. But you're right, Lucas. So sine is y, right? When you're going around, this is positive 1 for y, right? So that's at 90 degrees. So this answer is simply 90 degrees. Yep, you can put your calculator. It'll tell you 90. Sine inverse of 1. That one, you should kind of know that one over time without even using a calculator. You can use sine inverse of 1, it's fine. Okay, cosine of 0. Well, it's actually the same one, right? X is 0 here and here. So we do use the one that Lucas said, so it's 90 and 270. Because cosine hasn't moved, right? So cosine is 0. So on the y-axis. Now you're going to put it all together a little bit, just do a little bit of algebra, and you're going to solve for theta here. So what you're going to do for this last example, you're going to go, okay, minus 1, right? Just like you normally would. 3 tan theta equals 3. You divide by 3. Tan theta equals 1. Again, hopefully after the circle, you'll know where that is without using your calculator. But use your calculator. It's going to be 45. But tan theta, is that a positive 1 or a negative 1? I'm just asking you. It says tan theta is 1. Is that positive or negative? Positive. So I'm here, and I'm here. That's where tangent's positive, right? So 45, is that an actual answer? It is. And what's the other one? 225. So 45 is the reference angle, okay? So that's it, but we are in quadrant 1 because tangent's positive. 225 comes from this quadrant, 180 plus the 45. Okay, and that's it. All right.